Hello everyone, myself Shwetnisha. So today we are discussing calculus portion from your paper 1, questions that appeared in 2022 UPSC Mathematics Optional. So calculus plays a very important role, especially that is directly connected to a subject in your paper 2, which is real analysis, right? So this is the basis and every basic things that you need for real analysis. But real analysis is not the only subject. Calculus is a very basic subject in mathematics overall as well, because the concepts like differentiation and integration, they will be useful in many other subjects as well. So 2022 paper, we had some very intriguing questions. So let's discuss them. Let's solve them together. So let's start. So here we have questions. This is the format of your paper. Part A and Part B has four questions each, in which first question is mandatory to attempt. Question number 1 and question number 5. So first and 5 are mandatory to attempt in both of the parts, right? So I have highlighted here the portions which were in your calculus portion. From question number 1, you can see 2 questions are from calculus. That means you need to attempt that. These are mandatory questions. Other than that, question number 2B, 3rd B, and 4B. So these are all the questions. So let's start. First, we have this very simple limit. This you can do even if you have the basic knowledge from your class 11th, class 12th, the limit portion. It was that basic. Evaluate this limit. This was for 10 marks. Let's start. So I can start by taking let y is equals to e raised to the power x plus x raised to the power 1 by x, right? If I take log both sides, because I see a 1 by x here, so let's take log both sides. Taking log both sides, here we have log y is equals to 1 by x log of e raised to the power x plus x. Okay, now I can take limit both sides. Limit x tends to infinity of log y is equals to limit x tends to infinity of log e raised to power x plus x by x. If you directly substitute the limit, you can see this is log infinity by by infinity. So it's infinity by infinity form. Whenever you have infinity by infinity form, 0 by 0 form, you apply L'Hopital. So using L'Hopital rule, we can say on right hand side basically. So on left hand side, we have limit x tends to infinity log of y. That is equals to, we do differentiation in numerator also and denominator also with respect to x, keeping the limits as it is. So what will be differentiation of the numerator? That is 1 by, that is, and for x it will be 1. So this is e raised to the power x plus x, and then e raised to power x plus 1. And for denominator, it is 1, right? So this is your function. Let's try to apply limit on this side. I can take e raised to power x common. So it becomes 1 plus 1 by e raised to power x divided by 1 plus x divided by e raised to power x. So this becomes, because see, x goes to infinity, this is 1 by infinity, 0. And similarly here, okay, here I have x divided by e raised to power x, limit x tends to infinity. Do not confuse this. Do not say that it is just infinity by infinity. Actually, whenever you apply limits and you have to compare, because it's a numerator and denominator form. So in numerator, I have a polynomial. In denominator, I have an exponential. Exponential runs always faster than any of the polynomial, and polynomial runs faster than a log function. So this is the basic comparison you should remember when you are applying limit. It can be remembered in this way. Log is less than polynomial is less than exponential. So whenever you have to compare polynomial and exponential, think about only exponential, because exponential is leading the way. To forget about where this is going, actually, I have to only see where this is going. This is going to infinity. So it can be treated as just 1 by infinity, which is 0. Okay, make comparison. And if like this limit would have been like log x, right? So now this is again infinity by infinity, but log is now less than x. So that means x is leading the way because polynomial runs faster. So if polynomials lead the way, that means the answer is infinite. Okay. So with that reasoning, I can have this as 1 by 1. So my answer is 1. Now I can take the limit inside. It will be log of limit x tends to infinity of y is equals to log, okay, is equals to 1. Now, what I want to find is limit x tends to infinity of y, right? So I have to remove log, taking exponential both sides. I'll get, therefore, limit x tends to infinity of y is e raised to the power 1, which is e. That's your answer. That's the answer. E is the answer. So this was simple. Next. Next question was also from question number 1, mandatory section. Question number 1D. Examine the convergence. Convergence and divergence don't leave this topic. A bit of a practice of maximum number of questions are required. Other than that, if you remember all those tests for convergence, these questions are nothing, just a piece of cake. Okay, and look at the question. Question is also not a very, tricky question they have asked. They have asked a very simple question. This can be the simplest, this can be the easiest question they can ask from your convergence divergence section. Okay, so let's see. Now the given integral is this. Let fx be the integrand of your integration, that is 1 by 2x minus x squared, right? Let this be given. Let fx is equals to this. That's it. Now this is the integrand. Now then, what can you say about the continuity of this function? I can see there is a problem at 2 points, x is equals to 0 and x is equals to 2. They are the points of infinite discontinuity. So then I can say then fx has infinite discontinuity at x is equals to 0 and x is equals to 2. X is equals to 0 and x is equals to 2. So we have to deal them separately. Let me split the limits of integration from 0 to 1 and 1 to 2. So let us break the limit of integration. The limit of integration as this. So right now it is from 0 to 2, 1 by, okay, let me write it fx dx. That can be written as 0 to 1 fx dx plus 1 to 2 fx dx. Okay. Now, even if one integral out of these two is divergent, then I can say the total integration is divergent. Okay. So for integral 1, let me take it as I1 and I2. Same. So let us discuss I1 first. For integral I1. What is I1? Let me rewrite it here. That is 0 to 1, 1 upon 2x, or I can take x common here, x common 2 minus x dx. That is I1. Here 0 is the only point of infinite discontinuity. Here 0 is the only point of discontinuity. I can see in denominator I have a polynomial. So the best way to deal with it is the comparison test. I can assume that gx and because 0 is creating the problem. So what is the factor that is giving me 0? X. So what should be my gx? What should be the choice of gx? Continuity. Let gx should be 1 by x. Right? Then what is limit x tends to 0 of fx by gx? That is equals to limit x tends to 0, fx is 1 by x, 2 minus x, gx is 1 by x, so that will be here. Cancel out, answer is 1 by 2, which is a finite non-zero limit. When we have limit of fx by gx as a finite non-zero limit, then by comparison test, we can say that both the integrals, integration of fx and integration of gx, they behave alike. So whatever is the nature of integral gx, that will be the nature of the integral fx. Okay. Therefore, I can say by comparison test, integral of 0 to 1 fx dx, that is fx dx, and integral of 0 to 1 gx dx, they behave alike, right? So what is the nature of integral gx? That I can say by p test, they behave alike. Therefore, and before commenting on the nature of integral of fx, what is the integral gx behaving? How it is behaving? This is 1 by x dx, which is divergent. Why? Because for the p test, here p is equals to 1, right? So whenever, usually there is a confusion when it is greater than 1, then it is convergent or divergent. So, but for p is equals to 1, it is always divergent, whether it is the case of the series that you are taking or integral you are considering. So whenever you have 1 by x is to power p dx, where p is 1, that means it's divergent. Okay. Therefore, 0 to 1 fx dx is also divergent. So if one integral is divergent, that means the total integral is also divergent. And hence, I don't need to check for I2. And hence I, which is equals to 0 to 2, 1 by 2x minus x squared dx is divergent. Okay, that was it. So this is the answer. We have to examine the convergence, but this is not convergence, it is divergent. Next. So mandatory section was over. Now we have second question. Second question for 15 marks. This was Lagrange's method of undetermined multiplier. I always say this in the class as well, that some of the topics are like fixed. Like in calculus, some of the topics are fixed, that in these sections, you will definitely have an answer. A question. So, for example, if I talk about the subject that students are usually afraid, which is statics, dynamics, the physics portion, the 4 subjects from the physics portion. But if you look at the syllabus, you look at the previous year questions, some topics are fixed. Like from this topic, there will definitely be a question. So why don't we do those sections, even if I don't want to complete, if I don't want to take the complete syllabus, if I don't want to do everything in that, but you need to look at for the pattern that you have in your previous year questions. And for calculus, Lagrange's method of undetermined multiplier question will definitely be there. So it's better not to leave it. Let's start. What does the question says? A wire of length L is cut into 2 parts, which are bent in the form of a square and a circle. So total length is L. It is cut into 2 parts. It doesn't say 2 equal parts. So let me take it as, let's say, X and Y maybe. Using Lagrange's method of undetermined multiplier, find the least value of the sum of area so formed. Okay, so let us take, see, let wire of length L, wire of length L is cut into two parts of length x and y, right? Which implies x plus y is equals to L. This is, we are going to use it later. Now, what they are saying, find the least value of sum of areas so formed. So what will be the area of the area of this circle and the square? Area, but we know only the perimeter. We know circumference of circle and perimeter of square. So area of circle whose circumference is given. Whose circumference is x, which is pi r square. But what is circumference? Circumference is 2 pi r. From here, I can calculate what is r. R is x by 2 pi. And let us substitute here. Therefore, area of circle is pi r square. So pi x by 2 pi whole square, which is x square by 4 pi square. No, 4 pi, only 4 pi, that is cancelled. Similarly, for the perimeter as well, also, if perimeter of square is y, which means 4 into side is y. So side is y by 4, right? So what will be the area? Therefore, area of square is y square by 16. Sum of these areas, sum of area, that was x square by 4 pi, x square by 4 pi plus y square by 16. See, that's what they're exactly saying. Lagrange's method of undetermined multiplier, find the least value of sum of area so formed. So that's what I have done. I have taken sum of areas of circle and this. Now, I need to find least value of this using Lagrange's method. So to do that, we have a condition on it also. We have a condition that x plus y is equals to L given by equation number 1 here. So I have to take care of this. So we have to minimize expression 2. We have to minimize expression 2 with given condition as 1. With given condition as 1. Okay. So using Lagrange's method, what we do in Lagrange's method? Using Lagrange's method of undetermined multipliers. Undetermined multiplier. Let f, which is a function of x, y, and lambda. That is, so this expression I need to minimize, x square by 4 pi plus y square by 16, keeping in mind x plus y minus L. That I have taken from equation 1, right? So let it be third. Where, what is lambda? Lambda we need to calculate. Lambda is called Lagrange's multiplier. Lagrange's multiplier. Okay. So how to start? First, find their partial derivatives. Consider del f by del x is equals to 0 and del f by del y is equals to 0. Do differentiation with respect to x. That will be x by 2 pi plus, so with respect to x, it will be plus lambda is equals to 0. And with respect to y, it will be y by 8 plus lambda equals to 0. Okay, so what are the values of x and y here? X is minus 2 pi lambda and y is minus 8 lambda. So this is stationary point. Therefore, minus 2 pi lambda comma minus 8 lambda is a stationary point. From equation 1, I can find this value of lambda. So from equation 1, x plus y is equals to L, x plus y is equals to L. So lambda is minus L by 2 pi plus 8. So stationary points become substitute value of lambda here. That is, it will become 2 pi L by 2 pi plus 8 and 8 L by 2 pi plus 8. Can be simplified as taking 2 common. It will be pi L divided by pi plus 4 and 4L divided by pi plus 4. And what were the partial derivatives? We have fx. What was fx? This is fx, x by 2 pi plus lambda and y by 8 plus lambda. So fx is x by 2 pi plus lambda. Fy is y by 8. Y by 8 plus lambda. So what is f of xx? Partial differentiation of of fx with respect to x again. So that is 1 by 2 pi. Similarly, fyy would be 1 by 8 and f of xy is 0. Okay, so at this point, at the stationary point, what is the value of at pi L by pi by 4, comma 4L by pi by fxx fyy minus fxy whole square. Calculate. This is you multiply. This is 1 by 16 pi minus 0. This is 0. So it will be 1 by 16 pi, which is clearly greater than 0. Also, fxx comma fyy is greater than 0, right? Therefore, f attains minimum value at, f attains minimum value at pi L by pi plus 4, comma 4L by pi plus 4. Okay. And in question, they said, find the least value. We have to find the least value. So we got the point at which we'll get the least value. You substitute that in equation number 2. Okay, I'm using the space here. Here, this is. So what is the point that I want here? Want to substitute. This is the point. And least value of sum of area is, I'm using space here, and least value of sum of areas is equals to pi L by pi by 4 whole square, right? Divided by 4 pi, 1 by 4 pi, plus y square by 16. So 4L by pi by 4 whole square, 1 by 16. I can take L square common. I can take 4 common and pi plus 4 whole square common. So I'll get pi square by pi, that will be pi plus 4, no, sorry, pi square. Okay, L square common, pi square. We have taken this common, right? Other than that, we'll have a L square here. 5 by 4 and 4 out. I'll have a pi square here, right? And pi plus 4 square divided by 4. So that is equals to L square. I can write this 2 pi by 4 whole square. And this is pi plus 4. Yes. Okay, so that is cancelled, right? 5 plus 4. So this will be L square by 4, 5 plus 4. Okay, so this is the least value. Moving ahead. Next question. Third B, 15 marks again, double integration to calculate area of area which is common to the circle x square plus y square by 4 and the parabola y square is equals to 3x. For these kind of questions, you must know the basic knowledge of the basic functions, right? For example, circle, parabola, you must know how to draw their graphs. So let us draw circle, and we have a parabola. Y square is equals to 3. So this is the parabola. Given we have a circle, I'll call it C1, which is x square plus y square is equals to 4. And we have a parabola. And we have a parabola P, which is equivalent to y square minus 3x is equals to 0. First and second. These are the equations there, okay? Area bounded by these common area, I can see this is the common area. And because of the symmetric nature, I can, okay, let me redraw the graph. Yes. Let this, there are 2 points of intersection, A and B. Okay. So I'll calculate the area of this only, and then I'll multiply it by 2 to get the complete area. Okay. Let us find, first of all, point of intersection. Let us find point A and B. So y square is equals to 3x. This is from equation 2. Using this value, in equation 1, we get x square plus 3x minus 4 is equals to 0. So by splitting method, that is x minus 1 and x plus 4 is equals to 0. So x is 1 and minus 4. For x is equals to 1, what is the value of y? Y square is equals to 3 times 1, right? This is y square is equals to 3x. This is what I'm using here. So it implies y is plus minus root 3. But for x is equals to minus 4, y square is equals to 3 times minus 4, which implies y square is minus 12. Not possible. So this is a contradiction here. Okay, will not proceed from here. Therefore, 1 comma root 3 and 1 comma minus root 3. These are required point. These are required point of intersection A and B respectively. Now we can proceed. Here we can proceed by taking vertical strip. So vertical strip I have to take over here. Right, and one vertical strip I have to take on this side. So there are the whole area I have divided into 2 portions. This is the first portion, this is the second portion. Why we actually do that? Yeah. So why we do that? Because you see, if I move my vertical strip after the A point, what about the upper end of the vertical strip? If I talk about the vertical strip PQ only here, if I talk about the vertical strip PQ, so if I start moving it inside the area, inside the required area, then the upper point, which is P, is going to change curve after A point. After A point, it will be touching another curve, which is circle. Before that, it is touching parabola. So when this transformation occurs, we need to break that. Okay. Now, what is required area? See both of the areas separately here. If I consider it from in this very area, so let's talk about the limits. Limits of y, how it is calculated, because I'm taking vertical strip, so you have to do integration first. Integration first will be means inside the integration will be with respect to y, and later we'll have with respect to x. And how to find limit? See carefully. Lower portion, bottom of that strip is touching which curve? It is touching x-axis. That means y is equals to 0. Okay. The lower limit is y is equals to 0. Right. Upper limit means what is the portion of that vertical strip which it is touching which curve on the top, which is at P point. So P point is touching parabola, which is y square is equals to 3x, and it is on the positive side of the y-axis. See, it is above the x-axis, right? So I can consider only y is equals to I can consider y is equals to positive root of 3x. So it is under root of 3x. This is positive 3x. And what is the value of x? You start moving your vertical strip from the extreme left to the extreme right. Okay. When you do that, in the extreme left, what is the value of x? 0. In the extreme right, you cannot cross that A point here, that line. Okay. So you cannot cross that. So at that point, what is the value of x? Because I know what is A. Coordinate we know, 1 comma root 3. So what is the value of x here? 1. So 0 to 1. While finding the limits of y, you don't need to move your strip, that will be still. But when you're finding value of x, you move the vertical strip to the extreme left, to the extreme right, keeping the strip in the required area. Integrand is 1 because you are finding area. Plus, do similarly for this next one, dy dx. In the next one also, that strip, if I take it as, let's say, some mn, right? Then keeping it still in the lower portion, I can see that it touch x-axis, which means y is equals to 0. And in the above portion, it is touching circle. So I'll calculate y from the circle equation. But again, I'll take only the positive square root because that is above the x-axis. Only the positive. So under root of 4 minus x squared and 1 to 2. Why 1 to 2? Because if I move that vertical strip to the extreme left, here will be the position. Here x is equals to 1. And to the extreme right, it will just convert to a point, this point. And this at this point, what is x? 2. Why? Because the circle radius is 2. Okay, x squared plus y squared is equals to 4. So that's why from 1 to 2, these are the integrations that we have to solve. Let's solve. This is equals to, so 0 to 1, this is a root 3 root x dx plus 1 to 2 under root 4 minus x squared dx. In the next one, you will apply formula under root a squared minus x squared. And the first one, power formula, root 3 outside, x raised to the power 3 by 2 divided by 3 by 2. Limits 0 to x is equals to 0 to x is equals to 1. Plus, here, x by 2 under root 4 minus x squared plus a by 2, which is a squared by 2, so it is 4 by 2, and sine inverse x by a, which is 2 here, x is equals to 1 to 2. X is equals to 1, x is equals to 2. Now this is 2 by root 3 plus, if I substitute 2, so this will become 0. This will be there on substitution of 2. So I'll have 2 times sine inverse 1, which is pi by 2, minus, substitute 1. This side, it will be half of, I'll substitute 1 here, it is root 3. Okay, this is 2 and this is root 3. Minus, if I substitute 1 here, it will be 2 times 1 by 2, sine inverse 1 by 2, which means pi by 6. Simplify, this will be 2 by root 3 plus pi minus pi by 3 minus root 3 by 2. So this is going to be 2 root 3 by 3 minus root 3 by 2 plus 2 pi by 3. Root 3 common. This is 2, this is 4 minus 3 by 6 plus 2 pi by 3. So your answer is, this is 1 by 6, which I can write 1 by 2 root 3 plus 2 pi by 3. That's your answer. I would say that this also can be done with the knowledge of your class 12, not entirely, but this double integration is not in class 12, but we have done this portion of how to deal with, how to calculate the area. Okay, so We have done it here using the double integration. Other than that, there was simple integration, right? So you have to please make a separate list of your differentiation and integration formulas, but it should be on loose sheets, because throughout you will get some new formulas in each and every subject. So you are going to add them. You must have a formula list of differentiation and integration separately. And this will be useful in your ODE, PDE, and many more subjects. Now let's move to the last question, which is trace the curve. This was for 20 marks. So this is my given curve here. We have to follow one rule. This is just for the general knowledge. You don't have to write it in your exam. What is the rule that we follow to trace the curve? We only follow one rule, which is under root of SOAP, which is so simple. You can remember that by this. Now, what these represent? S means you need to check symmetry. Symmetry with respect to some standard lines, for example, x-axis, y-axis, y is equals to x, y is equals to minus x, about the origin. We have to check the symmetry about these. Then O means what? O means origin. If your curve passes through the origin, then you have to find out about the tangents at origin, which can be of the three types: cusp, nodes, right? We have we have discussed it in the class as well. So when the curve passes through the origin, then you have to find out the tangent. What is the nature of tangent at origin as well? Okay. And then what is A? A is asymptote. A is asymptotes. You have to find all the asymptotes, rectangular one, oblique one, all of them, asymptotes. Then P is, we have to look for some points as well. For example, where it cuts x-axis, what is the point of intersection of x with the x-axis, y-axis, y is equals to x, y is equals to minus x, right? And the last one is this under root. This under root represent region, domain, range, region, which means a domain as well as range. Okay, find out what is the range of this, what is the domain for this curve. Okay, if you remember simple formula, go by step one by one, you'll have a good idea about your curve and you can trace the curve. Okay, so let's start. First, you have to start by symmetry. You can mark them as like points also in exams, so that also you don't forget that you are not missing any point. Starting with symmetry. To find out the symmetry, we replace y by minus y and x by minus x. So this is minus y square minus x square is equals to minus x whole square minus a square, which is original curve, which is equivalent to y square x square is equals to x square minus a square, which is original curve. Therefore, a curve is symmetrical about both the axes, x-axis also, y-axis also. When this kind of situation occurs, the job becomes very easy. I'll tell you why. Therefore, curve is symmetrical about both the axes. So why about both the axes? So why job becomes easy? Because now I don't have to figure out the nature of trace in the whole R2 plane, because it is already symmetrical about y-axis. So if I can find the nature, if I can trace in the positive section of x-axis, which is on the left side, right side of your y-axis, that means it will be similarly on the x-axis, right? So if that is the curve, so this will be the curve on y-axis. And if it is symmetric about, so my job is only for this portion, okay? Now, if it is symmetric about x-axis also, that means I don't have to be worried about above the x-axis and below the x-axis both. Only I have to figure out one section. That means if you can figure out your graph only in the first quadrant, then you can draw the graph because it is symmetrical about both the axes. Okay, so whatever is the nature of the graph here, let's say this is the graph. So this will be the graph below because it is symmetric about x-axis also. Okay, so we are looking only in the first, how the graph curve looks like in first quadrant, only that. After origin, after symmetric point, we discuss about origin, whether it passes through origin or not. Substitute 0, it can be clearly seen 0 is equals to 0 minus a square, so that doesn't lie on curve. So origin does not lie on curve. Now, what about asymptotes? Asymptotes also, let's discuss asymptotes. There will be no asymptotes parallel to y-axis here, right? Parallel to y-axis. No, because I cannot write it in the terms x square. Okay, so what I can say is asymptote parallel to x-axis. They are what? We find that by equating coefficient of highest power of x is equals to 0. That is y square minus 1 is equals to 0. So y is equals to plus minus 1. These are your asymptotes. Next, after asymptotes, we have points. Let us discuss points. In points, for x is equals to 0, that means whether we have any intersection with y-axis. For x is equals to 0, you substitute that we have the curve y square x square minus is equals to x square minus x. So you substitute x is equals to 0. What you will get? You will get 0 is minus a square, which is a contradiction. Right? Therefore, curve does not intersect y-axis. What about y is equals to 0? For y is equals to 0, we have x square minus a square is equals to 0, which implies x is equals to plus minus a. Therefore, a comma 0 and minus a comma 0, it lie on curve. So we have 2 points which lies on curve. That means it intersects x-axis, but it does not intersect y-axis. Last, we talk about that under root sign which represent region. So we have y square is equals to, what is y square? This is x square minus a square by x square. Definitely this y square is greater than 0. So this also has to be greater than 0, which means y square is greater than equals to 0, which implies x square minus a square is greater than 0. Only greater than 0. Okay, no, greater than equal to 0, which implies x square is greater than a square. So x belongs to minus infinity to minus a union a to infinity. Okay, how we calculate that? See, x square is greater than equal to a square. You can get the graph. This is x square. Now, when I'm saying that it is greater than some a square, this is a square, right? It is greater than a square. So which section of the graph is giving you actually this value greater than a? This lower section of the graph is not contributing. So I'll just cancel this section. So basically only this section of the graph, and this section corresponds to which values of x? For this is x square. So this will be minus a. This will be a, and all the portion here, all the portion here. This will give me this section of the graph. Okay, so the values are minus infinity to minus a union a to infinity. Similarly, I can find out x. For x square, it's what? Also for x square is equals to, x square would be what? That would be taking common. So a square divided by 1 minus y square. Here x square is greater than 0. Here, see, x square is greater than 0 and a square is already greater than equal to 0. That means 1 minus y square needs to be greater than 0. It cannot be negative. So if it is greater than 0, it implies y square is less than 1. So y belongs to minus 1 to 1. That means the range of your graph should not be more than 1, should not be less than minus 1. And you look at the asymptotes. At 1 and minus 1, we have the asymptote also. So we have asymptotes as this. So hence, graph would be as shown below. From region, I got to know that x cannot be between minus a to a. So this is minus a, x is equals to minus a, and this is x is equals to a. Okay, so graph has to be in this section and this section. Let's talk about only this side, this very side. Over here, y is equals to 1 and y is equals to minus 1 are asymptotes. So y is equals to 1 and y is equals to minus 1. Okay. Point of intersection also we know. Point of intersection is a comma 0. So a comma 0 is here. From here, you have to draw the graph in such a way that y is equals to 1 becomes asymptote. So it has to be something like this. And when you have graph in the first quadrant, draw symmetric graph in this and similarly symmetric to y-axis. So this is the nature of the graph, and here you secure your 20 marks. Okay. This was it. These were all the questions. I hope this was very useful for you. So I'll see you in the next video discussing statics and dynamics as well.